Today, we are going to clear up one of the most confusing parts of data analysis, picking the right statistical test. And by the end of this, you're going to have a single one-page guide that makes it all incredibly simple. You know that feeling, right? You're staring at your data, you see all these terms, t-test, regression, ANOVA, and you're just thinking, which one am I supposed to use here? If you've ever felt that, trust me, you are not alone. It's a question that trips up everyone, but the answer is surprisingly straightforward.
So here's our game plan. We'll start with what's called the tragedy of statistics. Basically, why this is all so confusing in the first place. Then, we'll introduce just one concept that connects everything, which leads us to a magic single table. After that, we'll see how to actually choose your method, understand why it works, and finally, turn this whole thing into your new secret weapon for data analysis.
All right, let's kick things off with what the source material calls the tragedy of statistics. And this isn't about scary formulas. It's about a fundamental problem in the way we usually learn this stuff. You know, the source article calls this a tragedy for a very good reason. We're taught all these methods, t-tests, regressions, chi-squared, as if they live on separate islands. We learn the rules for one, then move to the next, but we're never really shown how they're all connected. So we're left with all these tools, but no idea which one to grab in a real-world situation. But what if I told you that most of these seemingly separate methods are not strangers at all? What if they're actually all part of the same family? This is where everything is going to start to click, all thanks to one single idea. The key that unlocks everything is a really powerful concept called the Generalized Linear Model, or GLM for short. Think of it as the unifying theory, the family tree that connects so many of the statistical tests you've heard of. And this is the light bulb moment. The GLM framework shows us that whether you're running a t-test or an ANOVA, what you're really doing is a form of regression. They're all just different dialects of the same statistical language, and they're all asking about relationships in your data. So because of this unifying idea, we can create an incredibly powerful tool, a single table that can guide all of our decisions and just cut through the fog. This is that one-page guide we've been building up to. And here it is. This is the magic table. It organizes everything you need based on just two simple questions about your data. First, look at the columns. Is your result the thing you're trying to measure? Is it a continuous number, like sales figures? Or is it binary, like a yes or a no? Second, look at the rows. What's the thing you think is explaining that result? Is it something split into groups, like an A/B test? Or is it also a continuous number, like ad spend? Just find where your row and your column intersect, and bam, that's the method you need. And just remember, all these different names on this table, they are all just special cases of that one big idea, the generalized linear model. Deep down, they're all regression. Okay, this all looks great in theory, but how do we actually use this thing in the real world? Well, the process is actually incredibly simple. Let's walk through it. It's really just 3 easy steps. First, you identify your result variable. What are you trying to understand? Second, you identify your explanation variable. What do you think is causing that result? And third, you just look it up on the table. That's it. Let's try it out. For example, say you want to compare the average sales between men and women. Okay, so step 1, what's our result? It's sales, which is a continuous number. Step 2, what's our explanation? It's gender, which has 2 groups, male and female. So we look at the table, continuous result, 2-group explanation, and it points us right to the t-test. Simple as that. Okay, let's switch it up. What if you want to know if visiting the store more often leads to higher sales? Our result, sales, is still continuous. But now our explanation, the number of store visits, is also a continuous number. So we check our table again. Continuous result explained by a continuous cause. And that leads us straight to regression. Now, you might be wondering, okay, I get the table, but how on earth can a t-test and a regression be the same thing? They seem totally different. And that is an excellent question. The answer lies in a pretty clever bit of statistical translation. Think of it this way. A t-test is a specialized tool. It's designed to do one thing and one thing only. Find the difference in the average value between 2 groups. A regression, on the other hand, is built to find the slope of a line, which we call a coefficient. The magic happens when we find a way to make that regression model calculate the group difference for us. And we do this using something called a dummy variable.
It's a simple but brilliant trick. Since a regression needs numbers to crunch, we just turn our categories into numbers. So for our gender example, we could just decide that the male group gets a 0 and the female group gets a 1. And just like that, our category can be plugged into a regression equation.
And here is the big reveal. When you use a dummy variable like this, the final answer from the t-test, that difference in means, is the exact same number as the answer from the regression coefficient. I mean, literally, they are identical. They're just two different roads that lead to the exact same destination. And this isn't just a weird coincidence. It's a fundamental mathematical fact. The famous statistician R.A. Fisher proved that both of these results follow the exact same statistical pattern, which is called the t-distribution. And that's why the p-values, the thing that tells you if your result is significant, end up being exactly the same. You're testing the exact same hypotheses. So, after all this, what does this actually mean for you? Well, this isn't just some neat party trick. This is a powerful new weapon in your analytical toolkit. It really changes your entire relationship with data. The bottom line is this: you can forget about trying to memorize a long, disconnected list of tests. You have a logical framework now. You understand that these tools are mostly just different flavors of regression, and you have a one-page guide to choose the right one every single time. It's a simple, powerful, and unified view of statistics. With this new perspective, statistics stops being about memorizing rules and starts being a powerful tool for asking questions. So the next time you face a data set, you have a clear, confident starting point. The only question left is, what story is your data waiting to tell you?